Chapter 1, Lesson 6 is on relations, and as you can see from the highlights over here to the side, this lesson has a lot of vocabulary as well. And I am going to use the book for this portion because their picture is much nicer than one I could draw on my own. Okay, a coordinate system is also known as a coordinate plane. So let me write that down just a little bit. And actually, you guys are probably more familiar with the term coordinate plane. They're the same thing. And they're formed by intersecting two axes, the x, which is the horizontal axis, and the y, which is the vertical axis. So here we have the y-axis vertical, the x-axis horizontal. The point 0, 0 here is known as the origin. Let's write these down. Y-axis is vertical, which means it goes up and down, kind of like the letter Y goes up and down. The x-axis is horizontal. It goes sideways, kind of like the Y doesn't go sideways. The origin is the point 0, 0. So both the x and the y are 0. Okay. Every point is represented using an ordered pair. So every point is represented with an ordered pair. And an ordered pair has an x value and a y value. So we look at the actual definition here as the set of numbers or coordinates written in the form x, y. Okay, so it's a set of numbers, two numbers written in the form x, y. Now, they don't have to exclusively be x and y. We could write any letters and represent an ordered pair depending on which variables we're currently using. But know that they're always in alphabetical order. To help you remember, x comes before y in the alphabet, so x comes before y in your ordered pair. The x value is called the x coordinate. So whatever number this is, that's the x coordinate. And then the y value is called the y coordinate. And these give us directions to the point. Think of them kind of like if we were talking about GPS coordinates. They tell us where something is. Well, the x and the y coordinate tell us where something is on a coordinate plane. It's a location. You know what they say, location, location, location. Right? If we have a set of ordered pairs, it's called a relation. So let's talk about a relation. It's a set of ordered pairs a graph, a table, a mapping, or an equation that describes a relationship amongst numbers. Okay, so it can be depicted as graphs, tables, mappings, an equation, and it is a relationship. So if you think of relation, relationship, it describes the relationship between the numbers. Right, the next one we have is a mapping. Okay, a mapping is, if you think about it, mapping is like a map. Mapping. is a pictorial representation of a set of ordered pairs. Or a relation. And so if we have, for example, a set of ordered pairs okay, to make a mapping of this, we create two boxes. The first box has all of our x's. The second box has all of our y's. And we write our x's in. And we write our y's in. And if we have the same number repeating, we only write it once. So here I have a 3 and then another 3, but I only need 3 there one time. And then we draw arrows to show how the numbers go together. 2 goes with 3, 5 goes with -8, 7 goes with 6, and 9 goes with 3. That's a mapping. It's a pictorial representation of a set of ordered pairs. We can have our mapping, the domain is the first set and the range is the second set. So let me go back up here and label those. I forgot to talk about that. Domain and range. And let's actually define domain and range. All right, domain is the set of independent values. Also our x values, also known as our input values. And then the range is the dependent value because the y values depend on the x value we choose. And so these are the output values. Okay, so those are mappings. Let's see if we've got more vocabulary over here. Here we go. Here we have 3 different representations of the same relation. So let's go over how this will work. Okay. First I have ordered pairs. Okay, and so they gave us 1, 2, -2, 4, and 0, -3. If I make a table, I have x and y. 1 goes with 2, -2 goes with 4, and 0 goes with -3. Same information. I can make a graph where I have a coordinate plane with my x-axis and my y-axis. I go over 1 and up 2. I go back 2 and up 4. And I can go over 0 and down 3. And that's my graph. And then I can do a mapping, which we've already kind of done that, but let's do it again. We have a box for my x's and a box for my y's. I have a 1, a -2, and a 0, a 2, a 4, and a -3. And then I draw arrows to show the relationship. All 4 of these show the same relationship. It's just a matter of how we're pictorially representing them. All right, so we are going to try this again with some examples. We're going to express the set of ordered pairs 2, 5, -2, 3, 5, -2, and -1, -2, and those should have commas between them, as a table, a graph, and a mapping. We already have it as a set of ordered pairs. So let's start with a table. So we make an X and a Y column, and I just put my X's on one side and my Y's on the other. There's my table as a graph. So first I have my coordinate plane. Of course, this is much nicer if I actually have graph paper. I do have a graph stamp, so if you want to borrow my stamp, just let me know and you can use that on your own paper. So I have 2, 5, 3, 4, 5, negative 2, 3, 5, negative 2, and negative 1, negative 2. So there's my coordinate plane, and now for my map. And actually we can label this, and instead of calling it X and Y, we can call it domain and range, just to get used to doing that. So I have a 2, I have a negative 2, a 5, and a negative 1 on my X's. And then for my Y's, I have a 5, a 3, a negative 2, and another negative 2. But remember, we only write them one time when we do a mapping. And then I draw arrows to show the relationship. Okay. So let's do another kind of example. And this example asks us to determine the domain and range of the relation. Okay, so that was the same set that we were just dealing with, so let me rewrite those. I have a 2 and a 5, a negative 2 and a 3, a 5 and a negative 2, and a negative 1 and a negative 2. So my domain are all of the X's, so 2, negative 2, 5, and negative 1, and my range is all of the Y's, so 5, 3, and negative 2, and again I have another negative 2, but I only have to list it one time. Right. Let's do another example like this, where we are going to express the set 4, negative 3, 3, 2, negative 4, 1, and 0, negative 3 as a table, graph, and mapping. And we're going to identify domain and range. Okay, so just the same thing as we just did. Let's start with a table. 4, negative 3, 3, 2, negative 4, 1, 0, negative 3. And then our graph, to make our X and Y axis. Of course, again, this is much prettier on real graph paper. So I have 4, negative 3, 3, 2, negative 4, 1, and 0, negative 3. And then our mapping. And for this one, I'm going to go ahead and use X and Y. And I'll show you why momentarily. So I write down my X's, and I write down my Y's, And then I have a -3 again, so I don't have to write it a second time. 4 goes to -3, 3 goes to 2, -4 goes to 1, and 0 goes to -3. And then I'm going to identify the domain and the range. Here's my domain, and here's my range. All right, the next thing we want to talk about are independent and dependent variables. Okay, the independent variable, as I mentioned before, is our domain, and this is the variable that determines the output. Okay, this is our input, and this is the one that either we choose or there is no choice. And by that I mean if we're talking about time passing. We don't choose for time to pass. Time just passes. So in almost every situation, time is an independent variable. Not in everyone, but in almost everyone. Okay, the dependent variable is the range. This is the variable the variable that is dependent or that depends on the choice made or the value input. This is the output variable. Okay, and typically speaking, the dependent variable is sometimes easier to identify because we're looking for the variable, the value that depends on something else. So if I'm talking about, for example, the cost of, 10 pounds of grapes, well, the dependent variable is the final cost because it depends on how many pounds of grapes we bought. So sometimes it is easier to identify the dependent variable than the independent variable. All right, so we are going to do some examples where we are going to identify the dependent and independent variables. Okay, the dance committee is selling tickets to the fall ball. If you can't read my handwriting, look in the book. The more tickets that they sell, the greater the amount of money they can spend for decorations. And we want to identify the independent and dependent variables. So let's ask ourselves, what number depends on the other number? Well, the money they can spend on decorations depends on how much money they have, which is the more tickets they sell. So money depends on ticket sales. So tickets sold is the independent variable. And money for decorations is the dependent variable. Okay, our next example. Generally, the average price of going to the movies has steadily increased over time. The price of going to the movies has increased over time. So the price depends on the time. Right? So the price of movies in 1952 is different than the price of the movies in 1970, which is different than the price of the movies today. So price is the dependent and time is the independent. Okay, so you just want to try to figure out which number depends on the other one, and then that's your dependent, and the other one is your independent. All right, next we're going to analyze a graph. So the graph represents the distance Francesca has ridden on her bike. Describe what happens in the graph. All right, I'm going to do my very best to draw this graph. So here I have time, and here I have distance, and we go up, and then we're flat, and then we go up. And so now we're going to describe what's happening in the graph. Okay, first, she's riding her bike. And her distance is increasing. Then she stops for some amount of time. And we know this because the distance is not changing. The distance is flat. Okay, so first she's riding, then she stops for some amount of time, and then she begins riding again. And that's this portion here, 3. So let's look at the other 2 examples in the book. Oh, that's not the book. Here's the book. We have driving to school. And let me enlarge this a bit. So what is happening during this graph? First, we're driving, then we stop, then we drive slower, and then we stop, and then we drive slow again. So we start driving fast, stop, drive really slow, stop, and then drive again. Okay, income. Our income is steadily increasing, and then we get a big jump, and then it kind of slowly increases, and then it doesn't change for a while, and then it steadily increases again. So that's how we analyze those graphs. Next, we will do the note-taking portion of this lesson. Chapter 1, Lesson 6, Note-Taking. We're going to write down what we already know about relations. And this could vary. Some of you may not know anything about relations. Some of you may know a lot about relations. So instead of writing that down, I'm going to write what we'll learn. And what we will learn is how to represent relations and how to interpret graphs of relations. Okay. We have some vocabulary, and we're going to use this vocabulary to fill in the blanks. Okay, the numbers 3 and 4 represent an ordered pair. Now, an ordered pair is just a location on a graph. In the ordered pair, 3 represents an x coordinate and 4 represents the y coordinate. And if we're not using x and y, the ordered pair is always alphabetical. So, traditionally XY, but it could be A, B, P, Q. Just remember it's always alphabetical. Arrow A, here's arrow A right here, is pointing to the y-axis. Now, the y-axis goes up and down, the letter y goes up and down. That's the best way I can think of to remember that. The letter B is pointing to the origin. And the origin is always the point 0, 0. And arrow C is pointing to the x-axis. Okay, we're going to complete a mapping to represent the same relation. We're going to complete the table, the graph, and the mapping. I don't know why it just says mapping. Okay, so 0, 1, 3, 3, 4, 2. On our points, I have 0, 1, 3, 3, and 4, 2. And then on my map, I put my x coordinates, my y coordinates, and then I draw an arrow to show which goes with which. So 0 with 1, 3 with 3, and 4 with 2. In a relation involving test grades, the more hours spent studying, the higher the grade. Identify the independent and dependent variables. Okay, the independent variable is the variable we have control over. So we control hours spent studying. So independent is hours studying. The dependent variable is the variable that then depends on that. So the grade depends on the number of hours you spent studying. So this is the dependent variable. And then the alphabet, we already actually talked about this. X comes before Y. Use this fact to describe a method for remembering how to write ordered pairs. Ordered pairs are alphabetical, always. And that is the end of lesson 6.